The Demoscene, a subculture of enthusiasts that have a passion for showcasing both technical and artistic skills through short and usually non-interactive demos. These are effectively real-time programs that display impressive graphics, music, and mind-blowing effects, sometimes considered impossible given the limits of the hardware. Originally for home computers, the Demoscene also became popular on consoles, and given the closed nature of most game consoles, the Demoscene also represents freedom, creativity, and breaking barriers. Its history can be traced somewhere back to the early 80s, alongside the home computer revolution. Software piracy was commonplace, and most games could not be copied easily, so game cracking was the art of removing that copy protection from the game. This was done by altering code for the game to circumvent the method used to protect it. The earliest ever game crack was Microsoft Adventure, a port of Colossal Cave in 1981. Sometime in the early 80s, crackers would add introduction sequences of their own before the game itself, known as intros. Berlin Bear by Berlin Cracking Service is considered to be the very first intro. This intro did not do anything special, just displayed a static image. Eaglesoft Incorporated, a cracking group from Canada, formed in 1982 and would go on to crack over 1,000 games. Their intros became legendary, with high-quality hand-drawn art alongside music, especially on the Commodore 64. As these intros became more sophisticated, often showcasing the coder's skills, they evolved into standalone creations that were in the public domain. Demoscene groups were formed and competed against one another. The rise of affordable 8 and 16-bit home computers provided platforms with enough graphical and audio capabilities to inspire experimentation. Programmers pushed hardware limits, optimizing codes to create effects that seemed impossible. But there would be other motivations. It provided a chance to show off a hardware platform to a larger community, showing off incredible smooth scrolling, more colors on screen that were thought possible, coupled with sound and music. Demoscene coders knew no boundaries. They knew how to extract the very best of the hardware, often using tricks that were never documented through discovery. The launch of the 16-bit Commodore Amiga in 1985 signified a turning point. While the first Amiga 1000 was expensive and out of reach of most, the more affordable A500 in 1987 became a cornerstone of the Demoscene, thanks to its advanced graphics and sound chips, with groups like the Silence, Red Sector, and Future Crew pushing boundaries. Demos would become more sophisticated, combining graphics, synchronized music, and storytelling. Unlike smaller demos which focused on a single effect or a short sequence, mega demos were extended, multi-part creations that would show off a variety of effects, music, and visuals, often pushing the limits of the hardware that they ran on. The earliest mega demos, while impressive, were essentially a disc with various intros loaded one after the other. Usually, when the user pressed the spacebar or clicked the mouse, it would pause and then load the next intro from disk. But they quickly would become more sophisticated. The Amiga could control the disk drive, graphics, and sound without interrupting the CPU, and coders would take advantage of this, allowing the demo to continue to run as the next section was loaded and unpacked from disk. The legendary Red Sector Inc. RSI Mega Demo from 1990 is one of the most well-regarded mega demos for its time. There are quite a few well-known effects in the Demoscene. These would become quite common, so a competition amongst demo groups to see who could break records of the most technically impressive effect would become a thing. For example, one of the most standard effects is the text scroller. Almost every demo out there has this. It's simply text that displays from right to left across the screen, usually to discuss the demo effect itself, shout out their friends and other scene demo groups, and proudly show off that they are the best. The Mental Scroll Over demo in 1990 shows off a large number of individual text scrollers, all with different messages, all running at different speeds. Text scrollers were also manipulated with pre-computed sine tables to provide vertical movement. The twister effect is another iconic Demoscene effect first shown on the Amiga. It simulates the twisting motion of some form of material. The hardwired demo by groups Cryonics and The Silence was first to show off this effect, and the demo was groundbreaking for its time. Other effects include a large number of fast-moving objects known as bobs, short for blitter objects. These are used for animation on the Amiga, with the main advantage over sprites is that the Amiga is limited to only 8 sprites unless you resort to multiplexing. With blitter objects, you can have a large number of them and they can be of any size. Often demos would try to one-up each other to see who could have the most number of bobs on screen at once. Shade bobs is a variant of blitter objects. When displayed over each other, they turn a different shade of color. But perhaps the most well-known effect is the raster or Copperbars. The name Copper comes from the Amiga coprocessor of the very same name, which is a very powerful custom chip that can be used for manipulating color without disturbing the main CPU, the Motorola 68000. The Copper is a powerful chip, and there are only 3 instructions to program it: move, wait, and skip. With these 3 instructions, it's possible to build what is known as copper lists. So rather than just talking about it, I decided to put my coding skills to the test to see if I could build my own small demo with scrolling raster bars. So I'm going to show you a demonstration in C code about how to create some really cool raster bars on the Amiga. Now this code should run fine on a stock Amiga 500, which is 512K of chip RAM. So this is a C program, and full disclaimer, the Demoscene probably is 99.99% of the time going to be using assembly language, but let's kind of walk through how this works. So the first thing we're going to do is create a structure of the copper bar itself. What does that look like? So if you think about a copper bar, you need to have a position on the screen where it's going to live. So we have a Y position. It also has to have a height of the bar itself in scan lines. It has to have a color value. In this case, because it's the Amiga, we're talking about a 12-bit RGB value, and a speed. In other words, how fast do we want that copper bar to travel down the screen? Now, I have defined my copper bars here, and we have 28 of them. So we've got a grouping of red bars here. We've got green bars, blue bars, and pink bars. Now, you can see that the red bar starts at Y position 52, and it ends at 64. Each bar has a height of 2 scan lines, and these are the gradient color values of red going all the way to hexadecimal F00. And you can see it starts at a pretty dark red, gets a little brighter, and it gets to the maximum red it can, and then it kind of decreases back. Now, the green bar is very much the same. It has the same height. It has a different offset position, goes from 66 to 78. Same thing for blue, and same thing for pink. Now, if we go ahead and run this program with our compiler, you'll see that we have a very standard demo effect, and this is the raster bars. Now this is, if you've used an Amiga and you've run any type of game that has a cracktro or an intro, then this is something you've probably seen many, many times. Now the Amiga doesn't have a concept of a frame buffer, but it does have bit planes. So we have to set up our bit planes in memory using chip memory, which is the memory that can be used for displaying graphics and audio. We're also setting up a copper list program, which also needs to reside in chip memory. When it comes to the Demoscene, one of the things that you have to do when you write a demo is to basically take control of the entire system. So you don't want any resident multitasking Amiga OS stuff running in the background. You want to basically take control of the whole system. Next function here is called setup copper. You can see now we're doing a little bit more setup here. We're setting up our DMA, we're starting our copper list program, and we're setting up our interrupt handler. Now this interrupt handler is very, very important, but we'll come back to that here shortly because that's where the copper list itself is being manipulated and it's doing its thing. One thing you'll notice here, this is our main loop. and you'll notice that there's nothing inside this loop at all except for a wait blit. And the only thing that this program is doing at this level is waiting for someone to click the left mouse button. Again, we had our copper list program, our Copperbars. You can see now if I click on the left mouse button, it's going to exit out of the program. So what's interesting here is that there's nothing actually going on, which means that the CPU itself is barely being used. Now, the interrupt handler is where we're manipulating and managing our Copperbars. Now, to kind of walk through how this works, the first for loop here, and I will say that this is probably not the most optimal way of doing things. I know there's probably some demo programmers that are just kind of shaking their head right now, saying that I would never do it this way, but this way gets the job done for me in this video. Now, this particular if statement is just a condition to let the program know once our Copperbar hits the bottom or the top of a screen that we want to just negate the speed. In other words, let the bars go in the opposite direction. I think a more appropriate way would be to use a pre-computed lookup of sine values to have that sine wave effect rather than just hitting the bottom and then negating its speed. Now, this next for loop is sorting our Copperbars. Now, I'll explain this in a little bit more detail, and I think the best way is to kind of show you what it looks like if I don't sort these Copperbars. And if we go ahead and run this without sorting them, what you'll find is that when these bars kind of hit the bottom, they all just kind of get messed up. So if we pause it here and take a look at what's going on, you see that the pink bar is never being displayed. And it seems like that the pink bar is kind of trapped behind the blue bar, but that's actually not the case either. What's happening is that the raster beam has already traveled further down than the pink bar is being displayed at. So the pink bar never gets an opportunity to render because remember, the raster beam always travels from top to bottom. So I have to provide some type of linear sort algorithm to ensure that the positions are always in order. Now, this next for loop is where we're doing our copper list manipulation. So for each of our Copperbars, we're getting the Y position and we're waiting for the raster beam to hit that Y position as well as a fixed X position. And once it does hit that particular position, we're setting its color value to the color that we had defined. Now, the next thing that we're doing is we're setting our copper list height that we had defined, which was 2 if we look at our list of copper list values here. And what's happening here is once the raster beam has hit that height value of 2 scan lines, the last part is to move the value black into the color 0 register. So you can see with just by manipulating some of the different values that we had defined that you can get some interesting effects. The Demoscene would also look at vertical Copperbars, which is something that was unheard of at the time. By carefully handcrafting copper lists, and with the right timings, it's possible to showcase an impressive effect. The plasma effect is another staple of the Demoscene. It's a continuous shifting display of colors, usually by cycles of changing colors warped in various ways to give the illusion of liquid or organic movement. Its implementation can be different depending on the hardware being used. 3D shade vectors are early 3D models that are flat shaded but have some form of lighting applied to them. The tunnel effect is also very common. They present a 3D style tunnel made up of vector lines or dots to give the effect of flying into a tunnel in the first person. Glens vectors are 3D vectors that have some form of transparency to give the illusion that it's made of glass or some type of transparent material. This is done by providing some form of additive blending. This effect is pretty cool and it demonstrates real-time 3D and mesh adjustments. Rotozoom takes a portion of the screen, applies it through a sine or cosine transformation, then applies a scale to that transformation to achieve the zoom and rotation effect. It's important to note here that the Amiga has no concept of a floating point unit, and because it only runs at 7 MHz, it would be awfully slow at computing this in real time. So like this and many other effects, optimization was key. Pre-built sine and cosine lookup tables were used to manage this, and the blitter was used to scale. Preloading as much data before runtime was the key to a fast and impressive demo. Oscillating circles was another popular demo effect. State of the Art by Spaceballs in 1992 was one of the earliest demos to showcase this effect. But it wouldn't just be graphics. Music played a pivotal role in the Demoscene, pushing hardware limits and showcasing creative and technical skill. Mod trackers use short digital audio samples as their source. These samples are then manipulated to create melodies and rhythms to allow for complex music within small file sizes. Trackers allow for precise timing control, which enables musicians to align musical events with visual effects in demos. Jesus on Ease is one such example. Released in 1992 on just 2 floppy disks, the entire demo runs at 30 minutes with the rave-style music running the entire way through, all while various demo effects are displayed, completely synced up with the music. The Amiga was a beast when it came to demo creation, and it was often said that the Amiga was the only place that many of these Demoscene effects were capable of running on. But all that would change in 1993, when Future Crew released one of the most legendary demos of all time. Second Reality featured 3D lens vectors, smooth scrolling, dot tunnel effects, oscillating circles, plasma, real-time colored spinning cubes, vector balls, roto-zooming, water effects, and even a 3D fly-through, all with a killer soundtrack running on a 386 PC. This was a turning point for the Demoscene. The PC was capable of going toe-to-toe with anything that the Amiga could do, and even improve upon it. And Second Reality has seen many ports to other machines, due to how iconic it is. Even the Commodore 64 saw an impressive version of the demo, complete with the iconic music. Although the Amiga would lose its relevancy in the 90s and the IBM PC dominated, the Demoscene never disappeared, and in many ways, running impressive demos on obsolete hardware is considered even more impressive than ever. Even on the PC, as CPUs and graphics hardware became more powerful, it meant that demo coders would set strict size limits to show what was possible. This is Nexus 8 on the PC, a remix of the very popular Nexus 7 Amiga demo by Andromeda. At face value, this doesn't seem all that interesting, until you realize its executable size is less than 8 kilobytes in size. This is quite remarkable to consider, that capturing footage for the demo is much larger than the size of the demo itself. There wouldn't be a Demoscene without demo parties. These are events where Demoscene participants can present their creations that can range from various local meetups to worldwide events such as assembly or revision. These competitions are for submissions in various categories. For example, 4K, 8K or 64K intros, old school Amiga demos, music and graphics compos, and to show off technical excellence and artistic creativity. Setting boundaries and artificial limits is what makes the Demoscene so interesting. Take for example the 8088 MPH by Hornet demo, which is a demo designed for a 1981 IBM PC with CGA graphics. This demo took first place in the old school compo at Revision 2015, and you can see why. It demonstrates over 1,000 colors on screen at once on a device that should only support 4 colors. It also has a real-time 3D sequence as well as vertical Copperbars. This is quite remarkable, and if you're interested in learning more about how this demo was created, there is an interesting technical write-up on good friend of the channel Jim Leonard's website. I'll leave a link in the description below. The Sinclair ZX Spectrum has also seen some incredible demo creations in recent times, and while the Amiga would also see hardware updates, the most impressive demos of all are the ones that run on a stock Amiga 500. And in recent times, some of the very best have been released, including Eon by the Black Lotus, and probably my favorite Amiga OCS demo of all time, Batman Rises. The entire demo oozes quality. It's an incredible narrative-driven demo that takes old-school Amiga concepts and applies incredible vector animation, and the technical excellence is off the charts. This is running on a stock Amiga 500 with a 1 megabyte expansion. For those that haven't been keeping up with this video, we're talking about a machine that released in 1985. But what about game consoles? Much of this discussion has been surrounding the demo scene on home computers, open platforms that allow for the creation of demos by using a multitude of tools and applications. But on game consoles, the demo scene also has a rich history. Consoles present a unique challenge to any would-be demo scener in that they are a closed platform. The development hardware and tools was simply not available unless you were a licensed developer or publisher that was partnered to build games for that platform. In most circumstances, the demo scener is required to use homebrew development tools and aftermarket hardware such as flash cartridges or an optical drive emulator to build and test their creations on. In more modern times, it's possible to use emulation, which can speed up the development process. Many demos that run on game consoles require precise timing, and sometimes will use undocumented features to show off some cool effect. So it's of the utmost importance that the emulation is also accurate. But the final step of this process is to always test the demo on real hardware. In later game consoles such as the Sony PlayStation, PSP and PS2, exploits such as mod chips or software vulnerabilities are usually required to run unsigned code. The motivation isn't piracy, it's about creative freedom and expression, and of course, to push the console hardware to its absolute limit. On the Nintendo Game Boy, the demo known as Is That a Game Boy in Your Pocket shows off incredible demo-style effects including twist scrollers, plasma, zoom text scrolling and much more with a bopping soundtrack, all at 60 frames per second. The NES featured an incredible demo called High Hopes released by the group Aspect. In 2007, this was a showcase with twist scrollers, vertical raster bars, texture box rotations, and vector balls. It even featured a built-in software speech synthesizer, all running on an NES with the 6502 at just 1.79 MHz. The Sega Mega Drive or Genesis has a very impressive demo scene, and it's no coincidence that the Motorola 68000 processor is the very same used in the Amiga and the Atari ST. But that's only half the story. Any great scene demo needs to take advantage of all the chips available. On the Mega Drive, that is the power of the VDB processor. Overdrive 2 by Titan won first place at Revision in 2017, and it's easily the best Mega Drive demo, and for my money, it's in the conversation as one of the best demos ever created. Many of the effects had never been seen before, and it was all due to a discovery of an unknown feature of the Mega Drive hardware. According to one of the developers of the demo, they would say, when we realized what we had found in the Mega Drive hardware, a register which enabled layer blending that no one else knew about, we had a choice: make a forum post about it or make a demo about it. We also knew someone would discover it at some point, but this awesome opportunity doesn't come every day. So we decided at that moment to do the right thing, exploit this feature and make the best demo that we could and release it at a demo party as soon as possible. Overdrive 2 captures everything that the demo scene stands for, pushing the Mega Drive hardware to its absolute limit. It features full screen with roto-zooming, blending, and a lightning-fast 3D engine, and the music is of some of the best ever made. It's an incredible experience, and if you're wanting to dive into the demo scene for the first time, but you don't know where to begin, Overdrive 2 is the perfect place to start. It's a masterpiece. So that's what makes the demo scene so damn cool. The vibrant creative playground where developers, artists, and musicians like to push boundaries of technology, from the roots going back to the 80s, the Amiga days, to the mind-blowing productions that we see today. The demo scene is a testament to human ingenuity and passion for creating something extraordinary. If you're a coder, or an artist, or a musician, or just someone that likes to see something interesting that captures your imagination, or makes you wonder how they pulled off that interesting technical effect, then the demo scene is probably for you. And there are many fantastic resources on the internet. Whether you're just interested in observing or want to get involved in the scene itself, it's certainly all available, and I'll leave various links to everything that you saw in the description below.